So, hi student, welcome back, and today we are going to continue our previous class, which is 2109 May paper 42, and we got little bit to go. So at page 17. So let's start with this question. We finished until AC previous time, so we are going to continue from here. Let's make it the screen bigger a bit. Okay. Copper can be extracted by electrolysis, correct or not? Copper can be extracted by electrolysis, usually by aqueous copper chloride. The reason is in a series of reactivity, we know that copper is quite down. So when we are talking aqueous, there is also liquid, which consists of hydrogen and oxygen ion. So if copper is not discharged, probably it will be hydrogen gas, unless the metal is more reactive than the hydrogen. Identify the ion to each electrode. So anode is which one? Also for here we know that this is battery. So here is anode, here is cathode. Okay, just follow the plus minus sign of the battery if that I give you. So anode will be the chlorine and cathode will be the copper. Okay, anode is positive, like negative chlorine. Cathode is the negative, you like positive is the copper. Okay, we are not going to details why is this discharge, because it is you can refer to series of reactivity. Series is a whole new chapter if we are going to go back to the to this thing. The scientists think that the compound Q, solution Q, is a copper chloride. So Q, where is the Q? Deduce the formula CuCl2. Okay, so it's a very straightforward question. Due to the charges, Cl is negative 1, Cu is positive 2, so it's CuCl2. Figure 9.1 show an electric power bicycle. So this is a bicycle. Okay, this is a complicated question, so let us read slowly. What you can do is, if you can pause the video and you can try to do by yourself in order to get the most out of this lesson. The battery has supply, let me read slowly again. The battery has to supply power to the electric motor. Okay, you need to imagine there's a wire to the electric motor, both front and rear lamp. So there's two lamp, one is to the front lamp, one is to the back lamp. So probably I imagine in my mind there will be something that something like this. In my mind now, there will be a battery. So the battery will go to the motor, and the battery will go to the lamp, go to another lamp, and then this one will combine all together and go back to the battery. This is what I imagine. I haven't put the switch, I haven't put the everything else, but there is the thing that I imagine when I read this question. A switch control the whole circuit. So probably I want to put a switch at here to control the circuit. The rider control the speed of the bicycle by changing the current of the electric motor. So now I need to change the motor, because I don't want to just switch on the motor and the motor moves. The reason is very dangerous. Can you imagine like a motor with camera, all the watt go in, and then the motor be full force? I mean the 100% full force motor will go in front, and then you will bang into something. Like car, you don't want to, like when you start the engine, you don't want to be gear 1 full force, full pedal go into, then you will just bang the people or thing in front. So you want to reduce it. The rider want to control the speed. So in order to reduce the motor, what we can do is we reduce the current. So we use a variable resistor at here. The reason I say resistor is to reduce the current. Variable resistor means you can adjust the current. You can go and buy just a few ringgit, few bucks on it, depend on how big is your experiment. Just a few bucks. So it's like something that you can turn. Usually it's something that you can turn. Sometimes it's switch, sometimes it's turn, but I prefer the turn one. So I think it's something that you can turn. When you turn high, there will be more current, the motor will move faster. When you turn to 0, it will be very slow, maybe 1, 2, 3, 4, 5, 6, 7, maybe something like that. Okay. The rider control the speed of the bicycle by changing the current. Okay, so it makes sense. I can imagine this in my mind. The two lamp is controlled by one more switch. So now I got one switch to control everything. The lamp are controlled by one more switch. However, if one lamp fail, the other lamp is still lit. So probably here there is how many switch? Wait, let me see. A switch control, yeah. So there'll be a main switch to control the circuit, and there is another switch to control the lamp. Okay, so there's one more switch to control the lamp. So probably I will put the switch at here because they say that there is one more switch. So I put the switch at here. I mean, if I cannot draw, the wire is combined together lah. The switch here, so there will be main switch in order to main switch, and this will be the second switch that control everything. The reason, and it stated that if one lamp fail, another lamp is still on. So probably this is a parallel wiring lah. You cannot, unless it's series. If series means one lamp broke, another lamp will break. But since it say one spoil, another will on, so that it will be a parallel, which I already draw parallel. These two lamp is arranged in a parallel, so I just keep it just like that. So the reason they put this switch, we can imagine that probably during the day you just need the bicycle to move, and you no need it to you only use the lamp during the night, and up to you lah. Here it put the main switch for the motor and the light bulb. I thought one switch for the motor, one switch for the light bulb, but up to the person, yeah, it still work, but it depends on the question. For me, I will put one switch for the motor and one more switch for it. I'll put it separately because I don't know, like car lah, you didn't start the car but you still can turn on the light. But the bad thing is, if you forget to turn off the light, then the battery will finish and the next day you cannot start the car. So there's pro and cons lah, whether you want to put the switch here or here, up to the person. Name a circuit component that can be used to change the current. Change the current. So what is the answer? So of course the answer will be variable resistor. Okay, variable resistor. To change the current. Ammeter is to measure the current, and voltmeter is to measure the voltage. Resistor is to reduce the current. It depends on the sign will be like this. Usually it's like this lah. Depend on like this is the sign, because sometimes you need to draw it. Sorry, this one also can but IG usually they do this. Sometimes they got two symbol. I don't know. Sometimes I don't know which symbol we want to use. Or this one is the resistor. And when we are talking about variable, you know variable. Actually, what is the meaning of variable? Okay, so variable from the word varies. You know variable, control variable, manipulated variable, constant variable. And when I'm talking to my brother, sister during an experiment, or what I mentioned is what are the other variable in the experiment, because it could be the experiment that you do. All experiment you do, there's no perfect experiment. Sure, there will be some variable. For example, like vaccination. Sure, got people die one, because there should be like 0.001% variable or 0.1% variable. Any experiment, medicine, or whatever case they study, but if it is too less, then you still accept it as the hypothesis, because we consider that as so far still good result lah, still a good result. So we call from the word vary. So variable means to change. Got many definition lah, but variable resistance means I can change the resistance. So so the symbol for it will be another arrow. Okay, so I want to draw this at the thing that I put at here, so that because the next question they ask us to draw. Complete the circuit diagram for this electric bicycle. Include the component that you name A1 and 2. So you need to draw this component up to you how you want to of course the student didn't get any mark lah, wasted. Actually maybe got a few mark lah, but I just put wrong.
Then what is the correct one?
Okay, so the correct one here lah, okay, let's try to do this because we do the imagination. I hope that you can know. Okay, first we draw the battery. Okay, we draw the battery. There's a and the battery goes to the main switch, correct or not? So I draw a main switch according to the question. I don't want to read the question, but okay, so there is a main switch to control the thing, and then it will go to the light and also go to the motor, correct or not? It will go to the light and it will go to the motor. So I draw the motor first. Okay, before it go to the motor, it will go to variable resistor. So I draw a variable resistor so that we can control the current of the motor. When we start the motor will turn on. And now the problem is the light. The light, maybe I draw here. The light, there's another switch. There's another switch for the light. And there is 2 light. So I just draw 2 light. And then I just need to connect everything. Yeah. I mean, draw nicely lah, draw something like this. So like this it will be. This one is also wrong. I forget to draw one thing. You can see what I forget to draw or not. I forget to draw the motor. So I just put the motor at here. Okay, I just put the motor at here. That should do. Up to you lah. If you put at here also, you know that the motor can work. If I want to put the motor at here, it also will work. So up to you lah. Here, as long as it's here, this line lah. So the student still get 2 mark because at least got 3 symbol and the light is arranged correctly, parallel. 1 mark gone because of missing variable resistor. Another mark gone because the
switch.
Yeah, because the switch is wrong. Because this switch means if you like this means I turn this but it's still not on. So I turn this, it will on the motor and the lamp, but this light is not on. So you need to turn on another light. So it makes not much sense lah if you want to design your bicycle like this, because when you turn the motor there's light and you need to turn on another switch to control another light. Maybe you just want one switch to control 2 light. That make more sense. Okay, so you need to able to imagine the thing. If you can imagine it, then you easy to draw. For guy I think it'll be easy lah. For girl I think it'll be harder because girl are more good in maybe mathematics. Guy are more good in space. That's why daddy usually know the road, which road to go, but mommy will be like, hey, where is this road? But of course girls are better in other things like language and other subject. The battery has an output voltage of 36 volt. That's quite high. And the current of the motor, or because it's motorbike, cycling, a motor is a maximum speed of 7 ampere. Wow, 7 ampere, so it's high, because your charger battery is only 5 ampere, right? If you got see your power bank charging. Calculate the power output of the electric motor at maximum. Power equals to volt times ampere. Then you you got 3 mark. Okay, the formula, the working, the answer, you get 3 mark. Very good. Okay, that's unit. The cyclist rider ride the bicycle at maximum speed for a journey. Of course, you don't really get maximum speed due to energy loss, due to friction and so on. Step 1, further quantify that to calculate the total energy. What are another thing that will influence the power? So of course another formula for power is this one, also you need to remember, where is power equals to work energy divided by time. If you still remember this formula, so by having time I can know the work. So the answer for this step 1, further quantity required, will be the time. The reason is the time will influence the power. If you study the formula, let's say that I give only 10 joule, but I do it in 1 second, so the power I have is 10 watt. But if I work 10 joule, I want to finish it by 0.1 second, which is faster. I got 100 watt. So means that if I move something faster, actually I'm using more power. So it makes more sense. Like when I go jogging, I like to run faster because I don't not like I'm very busy, but I want to utilize my time better. So I try to run faster so that I will use more energy. Then I don't know lah, in my mind lah, then I think that I'm saving time, okay, because I want to faster exercise and go and do other thing rather than jog slowly or cycling slowly. Of course, the thing that we do faster, then we will get more energy. So that's it for this paper. Thank you very much.